Hello everyone, this is Ksenia. I am the tutor for Trio Journey, and today I'll teach you guys how to balance chemical equations. Okay, So let's say you have an equation that is wait just a second. Like iron plus oxygen into Fe2O3. So the way you would start first is listing out how much of each reactant and product you have on each side of each element. So on this side we have iron, we have oxygen, we have iron and oxygen on this side as well. So on this side you see you have 1 iron and 2 oxygens. And then here you have 2 irons and 3 oxygens. So in order to balance this at first, you see you have 2 of these and 3 of these oxygens. And you only have 1 and 2, respectively, of iron and oxygen. So first you can balance the iron on the reactant side with 2 for the coefficient. Now you have not 1 but 2 irons. And then you see you have 3 oxygens on the product side, and now you need 3 oxygens on the reactant side. One way you could do, which is also correct, is multiply this oxygen by 1/2, which would give you 3 oxygens, but many professors would not prefer this method. So typically you would want a whole number for your coefficient. And in order to have these 3 oxygens, you might want to put 2 of these iron oxides. So you now have 4, and then you have 6 oxygens, because now you have to multiply this 2 coefficient into this 3. And that means you now have 4 irons. And now, since you have 6 here and you have 2 here, you just multiply this by 3, and you multiply 3 by 2, and that means you have 6 oxygens. And that's how you balance this equation. Next problem is, how do you balance something with carbons, hydrogens, and oxygens? So say you have C3H8 plus O2 turns into water and CO2. This is one of your basic combustion reactions, since you get a water and CO2, meaning carbon dioxide. So a way you might want to solve or work this kind of equation is writing out how many carbons you have, then hydrogens, and then write out how many oxygens you have, or the Cho rule. So in this question we have 3 carbons here, 8 hydrogens, and 2 oxygens. And then you have 1 carbon, 3 oxygens, because you also have an oxygen here, and then 2 hydrogens. So now that you have listed out all of your components that you have right now unbalanced, now you balance them out. So the first way is writing out how many carbons you have. Since you have 3 carbons in your propane, now you need to balance how many carbons you have on your product side with your carbon dioxide. So you can write 3 for your carbon dioxide. Now you have 3 carbons. You have 3 times 2, 6, plus 1, 7 oxygens, and you still have 2 hydrogens. So now that you have your 3 carbons, but now you need to find your hydrogens, since you still have 2 here and you have 8 on your reactant side. So the next thing you do is multiply the hydrogens from your water to find your H's. Since you have 8 H's on hydrogens on your reactant side, multiply your water by 4 to get 8 hydrogen. So now we manipulate this and we have 8 because we multiply our 4 from our hydrogen times 2 because of the coefficient on the bottom. And now we have balanced this, but we also have to multiply the waters. So we have 4 oxygens plus our 6. 4 plus 6 is 10 oxygens on this side. Now all that's left is to balance the oxygen on the reactant side. Since we have 10 oxygens on our product side, we can multiply the O2 here by 5. 5 times 2 is our 10. And this would be your balanced equation. Okay. And then another problem for balancing equations are ones with polyatomic ions. So say you have copper plus 2 silver nitrate into copper nitrate and then plus 2 silver. The same still holds as the previous. So you have your copper, your silver, your nitrogen, and oxygen. Your copper, silver, nitrogen, and oxygen. Okay, so in this case, you have 1 copper, your 1 silver, 1 nitrogen, 3 oxygen, and 1 copper, 2 nitrogen because you multiplied this N by the 2 on the bottom. That's silver, 1 silver, then 2 nitrogen because of the N being multiplied by the 2, and then oxygen, you multiply the 3 oxygens by the 2 here, so that's 6. So, okay, in this case, we have 2 nitrogens on our product side, and we need 2 more nitrogens on this side, and also 6 oxygens. The easiest way is to multiply by a 2 coefficient before our silver nitrate. This would then be still 1 copper on our reactant side, but then 2 silver on our reactant side, 2 nitrogen because the 2 multiplied by the 3 here, and then 2 times 3 because of this times this equals 6. And then on the product side, we see that we don't have 1 more silver because we multiplied this by 2 in order to get our nitrogen and oxygen. So we multiply this product and we get 2 silver. And that's our balanced equation. Okay, so next we have our silicon oxide plus fluoride, hydrofluoric acid, into fluoride and that's our water. So this same still applies. We write all of our elements, so silicon, oxygen, hydrogen, and fluoride, and write the same: silicon, oxygen, hydrogen, fluoride. You'd still probably want to do your oxygen after your hydrogen, so you might want to write it as silicon, hydrogen, oxygen, and fluoride, so you'd remember fluorine. Sorry. So we see we have 1 silicon, 2 oxygen, 1 hydrogen, and 1 fluorine. 1 silicon, 1 oxygen, then 2 hydrogen, and 4 fluorine. In order to balance this first, you probably want to get your hydrogens on your reactants. Actually, let's do our fluorine. So since we have 4 on our reactant side in our fluorine, we'd probably want the same amount on our reactant side. So you multiply this by 4 in your coefficients. So the silicon remains the same, the oxygen remains the same. Our hydrogen is now 4 because we multiply the 4 to our hydrogen. So 4 times 1 equals 4. And then 4 times 1 for our fluorine equals 4. The hydrogens here still remain the same. So in order to change that and get the right amount of hydrogens as we have on our reactant side, multiply this by 2. So we still have our 1 silicon. We have now 2 times 1, since this would always be 1. Now we have 2 times 1 for our oxygen, so that is now 2, the same as our reactant side. Then 2 times 2 is our 4 for our hydrogen. And now we still have 4 from our fluorine. And that's our new balanced equation. Same as if we do calcium sulfate plus sodium nitrate to calcium nitrate. Plus sodium sulfate. We do the same. Calcium and SO4. Since our sodium doesn't change, or sulfate doesn't change, and we have our sodium and our nitrate doesn't change. So sodium nitrate. Here we have 1 calcium, 1 sulfate, 1 sodium, and then 1 nitrate.
That's pretty good.
1 calcium, 2 nitrate, 2 sodium, and 1 sulfate. First thing you'd want to do is to balance the amount of sodium you have, since you have 2 sodium on your product, but you don't have 2 for your reactant. So you'd probably multiply this by 2. Your calcium still remains the same, your sulfate remains the same, but now your nitrate, your sodium, since we multiply 2 times 1, equals 2. And our nitrate also changes because of this 2 here. So you multiply 2 by this 1, because we don't change anything here. Then it now turns into 2. And that is our balanced equation. So I hope this has helped everyone, and have a nice day.